we've only changed the angle by 1 degree, and yet it has a significant effect on the performance of the diamond. Notice that for a good cut, some of the light is lost through the bottom of the diamond. Let's review this slowly. Through the table, some of the light's reflected upwards. That's good. But at this point, the light is reflected again in the wrong direction. It's reflected downwards. Why is that? Because this angle is greater than 24.4 degrees. It's 26 degrees. As a result, we have light escaping in the wrong direction. It's escaping downwards. Hence, the viewer could not see it. So for this small portion of the diamond, light's not reflected upwards. And through the facet, all the light entering through the facet is reflected upwards. So this diamond would still be very bright, but not as bright as an excellent cut because of this. This angle is much smaller than the previous angle, but also makes a good cut. Let's take a look. Notice that for this particular diamond, light entering through the table is reflected upwards. However, this time, light entering through the facet, some of the light entering through the facet, reflected at an awkward angle, not towards the observer. Again, why is this? Because this angle is greater than 24.4 degrees. And so as a result, some of the light is lost. Again, the diamond would still appear bright, but because of this small amount of light being lost, it would not be as bright as an excellent cut. Now, poor cuts are very rarely sold in the diamond trade, but this is an extreme example of a poor cut. This angle here, the pavilion angle, is only 23 degrees, and immediately all the light entering through the table would be lost, because this angle is less than 24.4 degrees. Another example of a poor cut is this diamond with a very large pavilion angle, an angle of 55 degrees. In this case, all the light entering through the facet and the table would be lost through the bottom of the diamond. These angles allow for total internal reflection to occur only once. Let's take a look and see what happens to light as we change the pavilion angle. We'll show light entering through the table and through the facet, but we won't show the geometry. So as we increase the pavilion angle, let's say to 30 degrees or 34 degrees, notice that the light starts to exit towards the observers. As we continue to increase that angle, light continues to approach the observers. And then if that angle gets too large, we begin to lose light through the bottom of the diamond. Notice that as we did this, the brightness of this diamond changed. We'll do it one more time. The next type of diamond I'd like to talk to you about is color. Some diamonds are not white or colorless and appear to have a yellow or brown shade. The more yellow or brown a diamond appears, the less valuable the diamond is. Letters are used to denote the color of a diamond, with D being the most valuable and colorless. Let's take a look. So diamonds can appear like this and have poor value, or like this and have high value. Another C of diamond, clarity. Clarity refers to the absence or presence of external or internal flaws. Internal flaws, also called inclusions, can sometimes be seen by the unaided eye, making the diamond less valuable. Diamonds with inclusions that can only be seen under magnification are in general more valuable. The inclusions absorb light, which in some cases results in the diamond appearing less bright and reflecting less light. So here are two inclusions that can only be seen under magnification. The inclusions in some way act as a fingerprint for your diamond, because no two diamonds have identical inclusions in the same position. Carat refers to the weight of a diamond. A 1 carat diamond has a weight of 200 milligrams. In general, as carat size increases, more light is reflected back to the observer. And of course, they cost more. The last topic I want to talk about is diamonds and fire. Fire refers to the different colors of the spectrum that can be seen when light travels through a diamond. Diamonds act like prisms, in that they have the ability to separate white light into its spectral colors, the colors of the rainbow. This process in physics is called dispersion. So let's take a look at that. Currently, white light is entering a diamond with a large angle of incidence. Notice that the light separates, and at this point when it exits, we can clearly see the colors of the rainbow. As we change this angle, notice what happens. As the angle approaches 0, light no longer separates and travels straight through. This is because for an angle of incidence that's 0, light does not refract. And when light does not refract, dispersion does not occur. Let's take a look at that one more time as we increase the angle. So for a large angle of incidence, we get dispersion. For a small angle of incidence, dispersion does not occur. So let's see what happens with a diamond. Notice that because initially, when light enters the table, it enters at an angle of incidence of 0, it doesn't separate into the spectral colors. Again, at this point, no separation occurs. Light's only reflecting. Same with this point. Again, light's only reflecting, therefore separation of colors cannot occur. But at this point, when light refracts, we begin to see the rainbow. Very little fire will be seen for light that follows this path. Now let's take a look and see what happens when light enters through the facet. When light enters through the facet, it enters at an angle. As a result, the light refracts, and when refraction occurs, dispersion occurs, and the light separates into its spectral colors. This separation is increased by the two reflections. Finally, we can see the light exit the diamond, and clearly the rainbow is much easier to see when light enters through the facet versus through the table. This is where most of the fire is produced, light entering through the facet rather than through the table for a diamond. So there's a trade-off. If you want a diamond with lots of fire, then you want very large facets and a very small table. However, as table size decreases, the amount of light being reflected back, or the brightness of the diamond, also decreases. So that's the trade-off between fire and brightness.